Hello my dear students, let us discuss about magnetism here. Okay, so now when a substance is placed in the external magnetic field, based on the behavior shown by that particular substance, the magnetism and the magnetic substances are divided into different categories. So first one is paramagnetic substance, the next diamagnetic substance, ferromagnetic substance, and the next antiferromagnetic substance and ferrimagnetic substance. So these are the 5 types we have, and out of these 5, the first 3 are very important to study. Okay, so these first 3 are very important to study. So let us understand one by one by looking into this. Okay, so now first one, diamagnetism and diamagnetic substances. See, the substance which decreases the external magnetic field. So here I will be explaining, look here. So for example, this is the external magnetic field which we are applying. Okay, so in this we are placing a substance here. Okay, now this substance will be showing what it is showing, what is the behavior it is showing. So now this substance is repelled by this external magnetic field. Okay, when these diamagnetic substances are repelled by this external magnetic field, it means it comes out of this field. This is one thing. And now one more thing you need to understand. So this is a magnetic, external magnetic field we are saying now. So now the external magnetic field, when we are taking it in the vacuum, okay, so the magnetic field, external magnetic field value in the vacuum, let us consider X. Now when we are placing this substance, when we are placing a diamagnetic substance in this external magnetic field, so the magnetic field value will be decreases. It means it is become lesser than X. Okay, so now read this. So the substance which decreases the external magnetic field strength, yes, so less than in the vacuum is known as diamagnetic substance. It means if X is the magnetic external magnetic field which we are applied, now when we are placing a diamagnetic substance in that external magnetic field, so its value become lesser than X. I hope it is clear, we can understand in this manner. Okay, now these substances are repelled by external magnetic field, and now you know why this magnetism is arises. So this arises due to presence of zero unpaired electrons. It means no unpaired electrons are there. So number of unpaired electrons should be 0. Okay, so here you can see, so the magnetism is arises due to absence of unpaired electrons. So it means number of unpaired electrons should be 0. Okay, so in these substances magnetic moment mu is equals to 0. Okay, this magnetism is temperature independent. So temperature independent, this line also you should remember, very important. So now unpaired electrons 0 means what? For example, here I have mentioned Zn plus 2. Okay, so if we take zinc sulfate or this kind of solutions. Okay, so now what happens in that, zinc is in plus 2 oxidation state. Now we know atomic number of zinc is 30, so it will be having 3d10 4s 0 electronic configuration, right? In its plus 2 oxidation state, it loses 2 electrons from 4s 2 electrons will be lost by this zinc and becoming Zn plus 2. Now it is having 3d10 electrons which are fully filled, which are paired up, right? So it will be paired up like this. Now, so all the electrons are paired up, so it means no unpaired electrons, so n value is equals to 0, so its magnetic moment mu will also be, spin only magnetic moment value mu is also be 0 Bohr magnetons. Hope it is clear. Similarly NaCl, look here, Na plus Cl minus. Now look into this, its electronic configuration, so it will be having now 10 electrons like neon gas configuration. All the electrons are get paired up now. So in the neon gas, how we will be writing 2s2 2p6, this is a valence electronic configuration. All the electrons are paired up, completely filled in the orbitals, right? So that's why it is diamagnetic substance. So chloride ion, here also 18 electrons are there now, so all the electrons are paired up. So for this chlorine atom, we should write it as 3s2 3p5, but it is becoming Cl minus now, so it is becoming 3d6. 3p6, all the electrons are paired up, so this substance is also becoming diamagnetic species. So complete molecule is diamagnetic substance. Even water also having 0 unpaired electrons, so it is also diamagnetic substance. I hope it is clear about this diamagnetism, and it is temperature independent, you can remember this. Okay, next let us discuss about paramagnetism. This substance which increases external magnetic field strength then in vacuum. For example, if this is the external magnetism, magnetic field we are applying. So in this, let us say this is a substance we are placing in this external magnetic field. So let us consider before placing this this substance in this external magnetic field, let us say it is having applied external magnetic field value as x. Now when we are placing a substance like some other paramagnetic substance, now it will induces the external magnetic field and it increases its magnetic field strength. Now the value will become x plus something, means its external magnetic field induced and value is increasing. So that is what increases the external magnetic field strength. Then in the vacuum is known as paramagnetic substance. Now one more thing you can understand here. So this paramagnetic substance is attracted by external magnetic field. Okay. So now this magnetism arises due to presence of unpaired electrons, For example, here you can see oxygen O2 molecule we are writing. So when we are studying about molecular orbital theory, so what we get to know, oxygen will be having 2 unpaired electrons. So N equals to 2 we are saying now. So it is paramagnetic substance we are saying. So it means any unpaired electrons are present, then that substance is considered to be paramagnetic substance. Now whenever it is paramagnetic substance, so its magnetic moment value will be having some value other than 0. So mu not equals to spin only magnetic moment value is not equals to 0. So it will be having some value. In order to calculate that, we can use mu equals to root over n into n plus 2 Bohr magnetons. Okay. So now where n represents what? Number of unpaired electrons. So here you can place this 2 here. So mu equals to root over 2 into, for O2 molecule I am saying. So 2 into 2 plus 2, 4. So it will become root 8. Okay. So now this value will be around what? So it will be around 2.83 Bohr magnetons. So this is how you can do. Hope it is clear how we are doing this magnetic moment calculation also, right? So the next, it is temperature dependent. Previously it is independent and this is dependent. So you can also remember these statements. Okay. So in the exam they may ask these statement based questions also. Next, ferromagnetic substance or magnetism here. So it is a spontaneous magnetism. And the next, in few metals by some intrinsic effects, what happens? Alignment of electrons in an orbitals takes place parallel way. So how the electrons are taking place? So they are aligned parallel to each other. So then the atom exhibits strong magnetic field. For example, iron I am writing here. So what is electronic configuration? 3d6 4s2. So it is having atomic number 26. It will be the electronic configuration. Now in this D10, D6 orbital, D orbital, 3D orbital, we have 6 electrons, right? So we can fill like this, 4, 5 electrons are filled. Now the 6th electron should be filled in this opposite manner, like opposite spin. But due to some intrinsic effects, so what happens? So if we look like this, it will be having how many unpaired electrons? 1, 2, 3, 4. So it should be 4. But due to the intrinsic effect, that electron, whatever oppositely filled electron will become parallel spin. So now 1, 2, 3, 4, 5, the 6th electron also having same spin. So now n value becomes how much? So how many electrons are having same spin? So all 6 electrons are having same spin. See, initially it is having only 4, now it is becoming 6. Now what happens? Number of unpaired electrons having same spin is increased, therefore its magnetic field also increases, or the magnetism shown by that particular substance also increases. So ferromagnetism means what? It's a paramagnetic substance will show or will enhances its magnetism and will become ferromagnetic substance. It means it's due to the parallel arrangement of these electrons in the orbitals, its magnetism increases. That is what happens in the ferromagnetic substance. Okay. So this is shown by these are the examples like iron, which we have taken here, cobalt, nickel, gadolinium, dysprosium, etc. Okay. So the parallel arrangement of electrons appears up to a particular temperature. It means if temperature is changed, so if temperature is changed, the electron distribution also become disturbed. Okay. So now the temperature at which ferromagnetic substance become paramagnetic substance. It means when it is having 4 unpaired electrons, we can say it is paramagnetic substance, right? Because having 4 unpaired electrons, so it shows paramagnetism. Now due to the like arrangement of this electron, which is oppositely arranged now, but it is becoming parallel alignment. So due to this reason it is becoming ferromagnetic substance, right? So now again this ferromagnetic substance, by change in temperature, see the temperature at which ferromagnetic substance becomes paramagnetic substance. It means by changing the temperature, so what happens, it become again paramagnetic substance. The temperature at which ferromagnetic substance, it means this substance again becomes with normal spin, it means it becomes paramagnetic substance. So that temperature is called Curie temperature. What is that? Curie temperature. Okay. Then next we have other two things also here. One is antiferromagnetism, another one is ferrimagnetism. These are really less important than the first three things. Okay. So now here in these cases, in a metal crystal lattice, the adjacent metal atoms unpaired electrons are aligned anti-parallel to each other. For example, two metals A, B are there, let us say. So now the electrons, if in this atom, if the electron is with this spin, so in this atom the electron will be with the opposite spin. Therefore net spin is how much? 0, right? They are having opposite spins. So therefore they can cancel out anti-parallel to each other. Yes. So one is clockwise, another one is anti-clockwise, you can understand. Okay. One is upside, another one is downside. Therefore net cancellation done and net spin will be 0. As a result, overall magnetic moment value becomes 0. So due to this opposite spin, so mu value will become 0. So they are known as antiferromagnetic substances or compounds. Okay. So now in ferrimagnetism, see in few compounds, in metallic crystal lattice, the adjacent metal atoms unpaired electrons, align parallel to each other. For example, A, B are there. Okay. So now it is having one unpaired electron like this. See, unpaired electrons are aligned. See, adjacent metal atoms, unpaired electrons are aligned parallel to each other. It means this will be also having like this, this is also having same spin. Okay, exhibit. Therefore, as a result now, like having same spin now, so spin value increases means its magnetic moment also getting increased. So therefore, they exhibit high magnetic strength. So they are known as ferrimagnetic substances. Okay, so this is because of the adjacent metal atom spin is like parallel to each other, therefore its magnetism enhanced because of their parallel spin, and this magnetism is decreased due to anti-parallel spin of adjacent metal atoms. I hope it is clear. Now I will be giving you one question here. So find magnetic moment, spin only magnetic moment value for this Cu plus 1 electronic configuration. So it is a Cu plus 1 species we have, oxidation state is plus 1. Now tell me mu n value, number of unpaired electrons it has, and what is its mu. So this you can do, and the next one is chromium plus 3. So how many unpaired electrons are there, and what is its spin only magnetic moment value. So here it is mu equals to x Bohr magnetons I am saying, and here mu equals to y Bohr magnetons I am saying. So what is the value of x and y in the comment box? You can write your answer. Hope it is clear. So this is your small homework question based on our discussion. Thank you for watching. Keep learning.